start. Good morning, good afternoon, good evening to everybody. My name is John Kyo, and I'm the chair and moderator of today's very exciting keynote and panel discussion. And of course, welcome to the Convergent Innovation Webinar Series at McGill University. Inventing one world solutions for lifelong wellness and sustainable economic growth. Well, what does that really mean? It's about capacity building. We're not here just to start talking or to have another webinar. This is capacity building, it's sharing knowledge. We want to come up with real world solutions at scale to address some major societal issues. And I'd like to welcome my guest co-chair for today is Dr. Anna Fensel. She's an associate professor at Wageningen University in the Netherlands and also at STI in Innsbruck. Anna has earned both her habilitation in 2018 and her doctoral degree in 2006 in computer science at the University of Innsbruck. And she has been extensively involved in European and national projects related to semantic technology. She's also been the organizer and program committee member of more than 100 scientific events and has authored more than 120 refereed papers. So we're delighted to have you as co-chair today, Anna. Now, over to our session for today. Before I introduce the keynote, Aaron Bradley, I'd like to give you an overview of the choreography for the event today. When I introduce the keynote will speak for about 30 minutes. After that, I will invite my co-chair and each of the panelists to comment for about 2 minutes on the keynote. If that's working well time-wise, then I'll invite the keynote back to comment on those interventions. After that, we rest the keynote and Anna will take over as co-chair and moderate a panel discussion for 45 to 50 minutes. If we have time, if everything is running well, we will go to a Q&A with the audience. If you do have questions, please put them into the chat box and I will be monitoring those while Anna is leading the panel discussion. The last 15 minutes we reserve for each of the panelists to do a 1-minute closing comment, followed by Aaron again as our keynote to do a 5-minute closing, and then myself and my co-chair will share the last 5 minutes for our closing comments. So with that, I'd like to introduce today's session and keynote speaker. It's Aaron Bradley. Aaron is going to talk about knowledge graphs in the field, the growing role of semantic technologies in the agri-food sector. Now, Aaron is a knowledge graph strategist at Electronic Arts in Vancouver, British Columbia. His background is in libraries, web design, search engine optimization, and that has allowed him to take a pragmatic approach to linked data technologies in his ongoing efforts to understand the potential of knowledge graphs and their application to solve real-life data challenges. So while his work at EA is currently focused on constructing connected content ecosystems, his interests in knowledge graphs is wide-ranging, and he is part of a community of practice that includes professionals from many different domains of knowledge and industry sectors. Aaron, over to you for the next 30 minutes.
Hello, everyone, and thank you very much for inviting me to this talk, John. As John said, I am knowledge graph strategist at Electronic Arts, which is to say I am the knowledge graph strategist at EA, and perhaps the only person in the world with that job title. It is, after all, a title I gave myself. Functionally, what I do is participate in the development of connected content ecosystems. That has next to nothing to do with the agri-food domain, but by using the word connected, I've already introduced you to the key theme of this talk, and by extension, what I think is the main characteristic and key value proposition of knowledge graphs. They allow you to make meaningful connections. When John first invited me to give this talk, I was somewhat trepidatious. I am more a strategist than a technologist, having spent, as he mentioned, in order more or less a decade each as a technical services librarian, a website designer, and a search engine optimization specialist, none of which have to do with this domain. Though in the spirit of exposing tangential connections, I can't help resist that noting my grandfather was a founding member of the Saskatchewan wheat pool. And my already permanent sense of imposter syndrome wasn't helped when John started announcing the panelists for today's session, which includes bona fide experts in both the agri-food domain and semantic technologies. I don't normally spend this much time on the About Me section, but insofar as people keep asking me to talk about knowledge graphs, I wanted to be as upfront as possible about why I'm passionate about them, what my superpower is when it comes to discussing them, and in aggregate, what you might glean from today's presentation. I'm passionate about knowledge graphs because they provide us with a way of making sense of things by virtue of the connections between them. To dreadfully paraphrase E.M. Forster, only connect, that is the whole of my sermon, live in fragments no longer. And so this subject was irresistible to me because I can think of no other domain where there are so many things that are so complexly connected to one another, and where there is such potential value in being able to understand and use these connections. Animals eat plants. Plants are processed into food. Food is a source of nutrients. Nutrients are required to grow plants. Plant growth is impacted by weather. Weather is impacted by climate. Climate is impacted by global warming. Global warming is caused by greenhouse gases. Animals emit greenhouse gases. Greenhouse gases are emitted by vehicles. Vehicles are used to transport food, and so on and so on. I didn't attempt to diagram even a portion of these connections. There are too many. But here's a fairly digestible graphic showing some of the domains of knowledge that intersect in terms of trying to make sense of agri-food data. This diagram is from the just published paper, Applications of Knowledge Graphs for Food Science and Industry, which is obviously very timely and to which I'll be returning later. Even this delicious diagram cannot adequately convey what's found in each of the segments surrounding the food knowledge graph. That's lots and lots of data. I'll try to reveal this in another way, and in so doing, reveal my superpower. When it comes to knowledge graphs, I am Homer Simpson. I am simple-minded, and so incapable of comprehending convoluted and arcane technical explanations, let alone providing them. And I think this is a superpower when it comes to talking about knowledge graphs, because I think they're conceptually quite straightforward, and yet so many efforts to explain them are convoluted and technical. And with that, here's finally something of an agenda for you. First, I'll give you my working definition of a knowledge graph. What is the nature of the beast? Next, I'll highlight some instances where knowledge graph technologies are being used in the agri-food domain. Sightings of the beast in the wild. Finally, I'll suggest some of the things you might want to think about if you want to start applying this technology. How do I prepare the beast for market? And somewhere in there, I'll have a word to say about decentralized knowledge graphs, but let's not put the cart before the horse. But speaking of beast, I first want to fulfill my promise of providing a hopefully straightforward example from the agri-food domain that illustrates how different domains of knowledge are implicated in such systems, and by extension, the power of connections. In passing, I'll also note that, like Homer, I am sometimes easily impressed because even thinking through this simple scenario kind of blew my mind. The beast in question is an ox, or a cow, or cattle. How things are referenced in semantic systems is actually pretty important, but I'll return to that later. This ox plows a field, and in this sense is a type of agricultural engine. In this field grows wheat, which ripens and is processed into food, which is in turn fed to the ox. Once fattened on the grain, the ox itself is processed into meat. In this scenario, the ox is both a producer of food, a consumer of food, and food. This is what blew my mind. And as I said, I'm easily impressed. But this scenario also reveals how useful data about an ox is likely to reside in different repositories that are related to specific domains. In one place, you might have data about the plowing potential of an ox and how that compares to other agricultural engines. In another, you might have data about the nutritional value of wheat per ox and how that compares to other types of oxen food. Yet another repository might have things to say about the nutritional value of beef for humans and how that compares to other types of food people eat, maybe even flour. What if I had the need or desire to use all of this different data, or even data from just two of those sources? How can I make sense of those disparate pieces of information? How can I combine them together? So it's time finally to talk about what we mean when we say knowledge graph. There's an entire cottage industry devoted to defining the term. In a resource list I maintain, there's 5 articles with the exact title, "What is a knowledge graph?" and countless others with the same intent. Our esteemed panelist, Ashley Faith, has an excellent video on the subject, which I encourage you all to watch. I won't attempt to summarize or even selectively quote them, excepting one that I'll talk about later. But I will give you the benefit of my Homer Simpson brain and offer up something that's not especially technical and I think hits the high points that characterize the knowledge graph approach. So my entry to the canon, honed over many years of attempting to answer the question, has at least the virtue of using simple, everyday words. I'll pause first to note the message that the multitude of definition more broadly conveys, and why I just said knowledge graph approach, is that having a knowledge graph isn't predicated on using any specific set of tools or adhering to a specific set of standards, or even by what having that graph enables, the more doctrinaire of the definitions notwithstanding. So a knowledge graph, says I, is a knowledge base of intelligently connected facts about things from one or more sources. Short and sweet, right? Every word's doing a lot of work here, so let me break it down for you. A knowledge base is involved, and without delving into the DIKW pyramid, suffice it to say that a knowledge base is not a database. The stuff that's in a knowledge graph is knowledge rather than data, in part because it consists of facts and the way in which those facts are connected. That those facts are about things isn't a sloppy oversight. I'm using things as a deliberately all-inclusive word. What sort of things? Buckingham Palace? Yes. Olive oil? Yes. The concept of love? Yes. If you can make an assertion about it, it's a thing. These assertions are what I'm calling, for simplicity's sake, facts. In the context of a knowledge graph, a fact isn't necessarily a true thing, but an assertion that has a structure that's compatible with the other facts in your graph. Intelligently connected means the connection between those facts are described just as precisely as the facts itself. William has genes from Elizabeth. Fluffy has genes from Tiger. This tomato has genes from that tomato. All fine and well, but you're way further ahead in your understanding of those facts if you also know what has genes from means. And that's what's being indicated if you ever hear someone say that relationships in a graph, those connections, are first-class citizens. And in that concluding phrase, from one or more sources, is buried the killer capability of this approach to organizing information. Knowledge graphs are an actual solution to the most persistent and prevalent problem in attempting to make sense of large amounts of data. How do I connect all this stuff? It's here I'll make my one definitional call out, because this piece from Kendall Clark of Stardog has always seemed to me to perfectly capture the primary value proposition of employing knowledge graphs, and one that couldn't be more pertinent to the agri-food domain. Unconnected data, Kendall says, is a liability, and unconnected data sucks. A knowledge graph is the only realistic way to manage enterprise data in full generality at scale in a world where connectedness is everything. Couldn't say it better myself, so I won't. But I will cheat a bit, and after saying I wouldn't quote anyone else, give you this from my friend and philologist, Theodora Petkova. It's not quite cheating because it's not from a What is a Knowledge Graph article, but rather an article on knowledge graphs in building automation systems. But when it comes to underlying principles, as you can gather from yet another image of connected entities, they're applicable across domains. To wit, this great summary. When it comes to turning data into actionable information, knowledge graphs have a proven record of offering a sustainable solution for harnessing and making sense of heterogeneous data. Humidity data and ventilation, recipes in restaurants, vegetable shelf life, and refrigerated shipping containers. It's all about being able to connect disparately held data. And to your now probable question, how are we able to make sense from different silos? The answer has, at least in part, been provided. It's by dint of those intelligent connections. It's how I'm able to understand that kittens and tomatoes both have genes, but with some other connections described in the same manners, that kittens are not an ingredient in pomodoro sauce, and even infer, by virtue of adding a few more facts from a recipe database, that Fluffy is probably safe in the kitchen of Patsy's Italian restaurant. For some, this ability to make such inferences, to reason, is a necessary condition of knowledge grafting. I'm not so sure, but I can say another enduring value proposition of knowledge graphs is their ability to generate new facts by being able to join together existing facts, and even facilitating the generation of knowledge in domains you weren't even thinking about. Sorry, another sort of digression, but in putting together this talk, fate kept tossing me irresistible examples of useful, potentially linked data. Like this from a book I'm reading on human evolution and anthropology. Here we see what one might regard as information from the Agri-Food domain, the nutritional value and yield of walnuts being used to inform our understanding of modern human society. I very much doubt that this inference was facilitated through using knowledge graphs, but it could have been if the implicated data had been liberated from its respective silos by being made interoperable through knowledge graph technologies. The specific way by which, in most knowledge graphs, this sort of interoperability is made possible is through the use of ontologies. There are almost as many ways of defining an ontology as a knowledge graph, but I think a key characteristic of an ontology is easily described. That being, it allows different systems to speak the same language. An ontology describes in precise machine-readable detail the relationships between specific types of things, how they're connected to other things, and the individual characteristics of each type of thing, what attributes they may possess. You've already encountered ontology in this talk because this ox field wheat diagram is actually an ontology, albeit a terrible one and lacking in attributes, designed using a graphical ontology creation and editing tool called Grapho. To continue this trip down the talk's memory lane and to use a better thought out ontology, I can also demonstrate how an ontology can be used to support my proposition that kittens are not typically an ingredient in Italian food. Google, Bing, Yahoo, and Yandex have developed an ontology called schema.org that allows publishers to describe the information they're providing to these search engines over the web. Don't at me, pedants, I'm calling it an ontology. While recipes across the web may be provided in a variety of formats, schema.org provides the mechanism by which all concerned can speak the same language. You don't have to guess what data values on a web page correspond to an ingredient or a type of cuisine because they're specified in that ontology. And so I could theoretically query an index of web accessible Italian food recipes and their ingredients to prove that Belus catus isn't used in those recipes because I and those recipe publishers have a shared understanding of what a recipe is and what an ingredient is and what a cuisine is. I won't attempt that proof though, because I feel pretty confident in my assertion here. Before moving on to more agri-food specific ontologies and linked data applications, this is a good opportunity to highlight a graph you're all familiar with, the Google Knowledge Graph. Indeed, while the approach has been around for some time, it was Google that in May 2012, almost exactly 10 years ago, introduced their knowledge graph and popularized the term. Every time you see a side panel, I missed these slides before. Here we see, though I'll point out, here is the schema.org representation, the ontology for recipes. Here is an Italian recipe. Here are the ingredients and the cuisine for that recipe, and there are no kittens. Here, in another knowledge application from Google, is the knowledge graph. Yes, so every time you see one of these side panels, you know that the information presented is pulled from the Google Knowledge Graph. And while schema.org annotations of the web are one of the inputs to the graph, Google is the poster child for meaningfully combining knowledge from heterogeneous sources. The most important of these being Wikipedia and Wikidata, the latter being a free and open knowledge base that can be read and edited by both humans and machines, and which acts as central storage for the structured data of its Wikimedia sister projects, which include Wikipedia. Google's mission is to organize all the world's knowledge. While the agri-food domain is vast, it's not all-encompassing, and someone trying to solve the problem of connecting data here is going to want to use ontologies that are once more limited in scope than used by Google, and more detailed when it comes to the specifics of the domain or domains you want to understand. One of the most cited food ontologies is Foodon, which describes food sources, categories, products, and other aspects of the food domain, which can serve, to quote the paper on knowledge food graphs, I said it earlier, and from which this simplified representation of the ontology you're seeing is now taken, to increase global food traceability, quality control, and data integration. Foodon was created in 2018. A much older vocabulary of terms in the agriculture, fisheries, forestry, and food fields is Agri-Food, released as linked data in 2011, with roots going back to the 80s. I wanted to call it Agri-Food because per the framing you can see here, it's actually a thesaurus rather than an ontology, and as such is more limited in its expressiveness, in particular to the types of relationship between entities it can describe. I'm highlighting this by way of saying, well, ontologies are perhaps the most useful type of vocabulary for knowledge graph applications. Others, thesauri, taxonomies, even simple term lists, also have value in such applications, especially as with Agri-Food, they're constructed to make available, constructed and made available according to well understood standards. More recently, there's been a lot of work dedicated to developing robust ontologies in the agri-food sector, and leading the charge in the agricultural domain has been CGIAR, now known by this acronym, but formerly the Consultative Group for International Agricultural Research. And we're fortunate to have Marie-Angelique Laporte on the panel today, who is active on the ontologies community practice of the CGIAR Big Data Platform, and who I'm hopeful will have more to say about her work here and teach me how to pronounce the acronym. Their agronomy ontology, agro, is an important ontology of concepts relevant to the agronomic practices, techniques, and inputs. An important trait agro shares with other contemporary, well thought out ontologies is that, to quote a page about its structure, it reuses and builds on existing terms from other ontologies, a list of which you can see here. They also maintain this excellent and useful list of the most used ontologies in agriculture, spanning the gamut from genes, remember them, to agriculture, to nutrition, along with generic ontologies and thesauri relevant to the agricultural domain. And that is a good point to move on from ontologies, as they in themselves facilitate the construction of knowledge graphs rather than themselves being knowledge graphs. Possessing an Oxford English dictionary doesn't give you a novel. Having the means to connect data from different sources only has utility if you have some data you want to connect and a reason for doing so. That collection of connected facts means the knowledge base to which I made reference in my definition. An increasingly common use of knowledge graph across different domains is in generating recommendations. Knowledge graph technologies are employed by LinkedIn to recommend jobs to its members, Airbnb to recommend rentals to its property browsers, Netflix to recommend movies to its subscribers, and Spotify to recommend music to its listeners. And knowledge graphs are also used to recommend food to diners. In fact, one of the earliest and most cited works on ontology development, published by Natalia Noack and Deborah McGinnis in 2001, developed an ontology of wine and food and appropriate combination of wine with meals, and was used in 2003 to create a demonstration for a recommendation system that would provide suitable wines for a given meal. A notable contemporary application of this approach is FoodKG, which combines recipe data, nutrient data, and food knowledge from Food On, no less, to provide an integrated food suggestion service that encompasses food and recipes that consumers who want to eat healthily encounter on a day-to-day basis. FoodKG also explores the potential application of their knowledge graph for answering natural language queries about food recommendations, as have others. And in general, knowledge graph question answering, KGQA, has become an important area of research and application development because of the complexity of QA systems and how well suited knowledge graphs are to tackling the task. A subset of this work is chatbot development. And whether you think of them as QA systems or chatbots, Google Assistant, Apple Siri, and Amazon Alexa simply wouldn't be successful without employing knowledge graph technology. In fact, one of the driving forces behind the development of the Google knowledge graph was a world gone mobile. Said Google's Amit Singhal, our heads explode when we think about this. Mobile QA capabilities are what drove the development of Agribot, a virtual assistant for Indian farmers. While not specifically built on top of the knowledge graph, the application does use graph adjacent technologies that include sentence embedding, entity extraction, and entity disambiguation. Agricultural question answering is also cited as potential application of the proposed Agri-KG agricultural knowledge graph, which would ambitiously automatically integrate massive agricultural data from the internet, and by applying NLP and deep learning techniques, automatically recognize agricultural entities from unstructured text and link them to form a knowledge graph. Another knowledge graph adjacent area being pursued in Agri-Food is the use of digital twins, which are a digital representation of real-world objects using structured machine-readable data. Well, digital twins don't require knowledge graphs. Knowledge graphs offer an elegant solution to the creation of digital twins that require using large amounts of information that resides in disparate repositories. Again, the desiloing of data. This is the case with the universal digital twin developed in the UK, which is built on a knowledge graph to aid in making decisions concerning land use and biomass resources. It employs ontology for land use classification, geospatial description of land use, and one onto crop energy that allows land use to be related to the yield and calorific value of the biomass made available by the land. While digital twins and Agri-Food are still in their infancy, their use is being explored in both the agricultural and food processing domains. Which brings us to the last area I'd like to look at in this brief survey of Agri-Food knowledge graph applications, which is very much related to digital twins and especially the Internet of Things, supply chain management. If you look at a typical supply chain diagram, it's invariably represented linearly. And that certainly makes sense for what's being represented. It's a chain. but things that appear at all stages of the food journey have all sorts of connections to one another besides the ones with their neighbors on the chain. And that chain can also more accurately be thought of as a journey through a web. That complexity, I think, is admirably represented from this diagram from Deloitte on some of the real world supply chain questions that could conceivably be answered by a knowledge graph. As does this graphic of supply chain interdependencies from Neo4j. And yes, for those of you that care, what Neo4j supports aren't semantic knowledge graphs, but they're still knowledge graphs. And with that, I'll now give my nod to decentralized knowledge graphs and their role in supply chain management, and in particular to the provision of trusted information about what ingredients are actually a part of food that reaches consumers. The problem of trust is central because, you guessed it, data is often stored in silos at every point in the supply chain, which is a barrier to effective traceability. That last quote is in relation to the Origin Trail protocol developed by Trace Labs, which I'm a little hesitant to cite because both John and I are advisors to the firm, and I don't want to appear to be shilling for the company. But decentralized knowledge graphs, DKGs, are just starting to emerge, and Origin Trail is the locus of DKG development right now, particularly as it pertains to food supply chains. For the record, there has been other work undertaken on DKGs, but so far as I know, none of these touch directly on food supply chains. In brief, DKGs use blockchain technologies to establish provenance for data as it's exchanged between different organizations. It is decentralized because it uses an off-chain peer-to-peer network that combines supply chain data from different IT systems. It is a knowledge graph because it uses standardized technologies to integrate data from these different sources. I'm hesitant to say more because nothing fries the Homer brain faster than talking about blockchain. But I'll conclude by noting that while many, and with good reason, equate blockchain technology with the shady world of cryptocurrency speculation, there are legitimate reasons to enjoy NFTs, especially in supply chain scenarios where provenance and traceability play important roles. Hopefully I've succeeded in what I've said so far in piquing your interest in knowledge graph technology, if you weren't already familiar with it, and that you started to think about what sort of problems knowledge graphs might solve in your particular niche of the agri-food world. So let me conclude by suggesting some things you might want to keep in mind if you aspire to travel some of the semantic pathways I've described. As usual, I'll keep it simple and anchor my advice on this unassuming looking article written by Tim Berners-Lee in 2006, which contains the most important 43 words ever written on the semantic web in the form of his 4 rules of linked data. The first of these is use your eyes for things. Recall that thing from before, the ox? How do we refer to it? Ox, animal/cattle, wikidata.org/wikiq830. It should be the latter. One of the things that inhibits data in different systems from being used together is the use of disjoint and duplicative identifiers. In many knowledge graph initiatives, a huge amount of effort is spent on resolving and disambiguating identifiers. Using your eyes, we would now say IRIs, that per rule 2 are HTTP resolvable, is the first step in solving some of these identity challenges. With regard to the use of linked data standards like RDF, OWL, and Sparkle, I advocate a common sense approach. Because RDF is self-describing, in many, if not most situations, it seems the biggest bang for your buck. But deviating from the standards isn't heresy and may better suit your specific use case. However, the more in which you express information you'd like to share in a standardized format, the better ahead you'll be. That's sort of the principle of fair data, data which meet principles of findability, accessibility, interoperability, and reusability. On that note, I'll recommend to you this recent post from Andreas Thalhammer, who calls out the role of the standards, and specifically RDF, in supporting the interoperability pillar up there. And let me conclude by saying that while using the standards helps, interoperability remains a major issue in the semantic web. Indeed, this challenge is the subject of a just published study where John is a contributing author. The author's recommendations keep interoperability top of mind, with academia forging closer links with industry, governments, and standards organizations to develop more effective models. Indeed, so I conclude more or less where I began, only connect. Thank you.
Aaron, thank you so much for that insightful and thought-provoking session. Really a lot of information there to unpack. For the audience, we're going to go into a 20-minute session right now where I will ask each of the panelists to comment for 2 minutes. I will introduce each of the panelists briefly. Starting with, I'm going to start with my co-chair, Anna Fensel, who I introduced earlier. After that, I will go through the panelists alphabetically by first name. And if we're going well on time, I will invite Aaron back to comment on those. So over to my co-chair for the first 2-minute intervention. Anna, your thoughts on the keynote today.
Thank you for the keynote. I think it's a very nice introduction to the topic of knowledge craft, also in relation to Agri-Food and some of the challenges which we are facing. For example, how to apply knowledge craft in decentralized scenarios, transparent issues. So.
Wonderful. Thank you, Anna, for those comments. Now I'd like to introduce our first panelist, Dr. Ashley Faith. She's the Director of Platform Knowledge Graphs, Semantic Search and MLAI at EBSCO Information, that's EBSCO. Her PhD and continued research efforts focus on advanced semantics and bridging the gap between users and information. She has worked in the search and data community for over 15 years, working with B2C and corporate and government entities such as GM, NASA, NATO, Gulfstream, Department of Defense, and others. And she also has an amazing educational website or platform on YouTube and is doing some tremendous work there. Ashley, over to you for your 2-minute intervention on the keynote.
Yeah, thank you for that. I was not prepared for the amount of information and other influencers in this space that Aaron even presented to me that I wasn't aware of. This is, we need a knowledge graph just for that. But, you know, one thing that really I think is a highlight is, and Aaron did such a good job at setting it up in the very beginning, where he walked through all of the interconnections between the ecosystem that we call our world right now. And I think that that's really where I resonate with the most, because I work right now at an academic aggregator where we are aggregating content across all the different types of content out there. And one thing that I have noticed building out my knowledge graph to connect those things is there's a lot more in common across multiple disciplines than we probably realize. So as an example, aerospace materials are apparently used a lot in medical devices. Who would have known until we made our knowledge graph and found those connections? Mm-hmm. So that's something that I think is one of the more powerful pieces to knowledge graph. You might hear it and think it's kind of buzzy, that it's uncovering new information that you might not have realized before, but it really is showing you connections that otherwise would be very hidden in traditional relational databases. And I call these hops. How many hops away do you have to realize how Aaron and I are connected together, or how myself and John are connected? Those are the really interesting pieces that you can discover with knowledge graph. So I see in some of the comments here folks are talking about these great ontologies in agriculture that they're going to go and check out. I would encourage you to go and look at other ones as well. BioPortal, for instance, is a great open source for other ontologies and ontology-like structures. They're not all ontologies, but the reason I point this out is you can learn a lot, especially I would say from the medical space, because they were doing a lot of ontology before the rest of us were doing it. Seeing what they do and maybe even borrowing from some of the things that they do is incredibly important if we are trying to get that interoperability, because what we are all talking about here, agriculture, there are so many different subsystems to how this works and how it's going to be successful, and the risks that we have to really think about, that having that interoperability with other disciplines, I think is something that we can't overlook here. So other examples, NASA has a great ontology. I'm sure you are all familiar with Agricola, right? That actually goes into other languages. So I call that a gateway ontology into other ontologies that might actually connect in. That is the beauty of using these standards. It's not just making it interoperable for your systems and what you want to do with it. It actually makes it so that you can actually use some of those connections that you make to connect to even more things. Mesh is a great example for that. Yeah. So I will top there.
Yeah, great intervention, Ashley, and very, very important. I think Aaron was implying this as well, the notion of systems thinking and connected systems or ecosystems as it relates to food. Because we know now when we have a shock in the system, like a pandemic or strife, that we have cascading consequences of system failures. And this is why it's so important to look outside of your comfort zone.
Exactly.
So thank you for that, Ashley. Our next speaker is Carlos Quiros. He's a senior digital developer at Bioversity International, where he provides support in the area of ICT4D. Now, I don't know what that ICT4D is, Carlos, so you'll have to help us understand that. And research data management. He's been actively involved in ICT in numerous successful implementations, multi-country projects in Africa, Asia, Latin America, and he's currently focused on providing leadership and strategic guidance on how ICTs can address global agricultural challenges. So, Carlos, over to you for your 2-minute intervention.
Hello, everybody. Thank you very much for the opportunity. ICT4D is basically ICT for development. What we create inside CGR, what we create is technologies or ICTs, to tackle the challenges in agriculture around the globe. In terms of knowledge graphs, is something that we are very interested in CGR. As you have seen, we have created a lot of ontologies over the years. Agri is one of them. The crop ontology is another. All of them are publicly available. And we are very, we've been very, try to integrate different sectors on that. Recently, we're trying to integrate with Bayer and others in order to explore even knowledge graphs. And I think coming from my area of expertise, which is data and data management, one of the biggest challenges that we have seen on knowledge graph is how scientists in our conglomerate of centers produce data, and from that they produce certain facts in the terms of publications, but then transforming those facts into interconnected facts into a knowledge, is something that we have seen very little, because sometimes the bar, for really, or the learning curve into learning this kind of application technologies is quite hard for them. Usually what we approach them and trying to make them, look, if you create this knowledge graph, you want to learn about all this set of knowledge, and they are fascinated by that fact, and they are fascinated by that potential. But when they try to make it themselves and approach into that new domain of expertise, they are like swimming in a sea of concepts and even something that they cannot even know. So I think it's like as I see, like maybe in our group, and even in this chat that we have today, we have seen a lot of people that they have known and they have used knowledge graphs, but when we're trying to correct people from another domains into this domain, the learning curve is quite hard. So I think it's like one of the things that I would see for the future in knowledge graph is how we can incorporate those people, or how we can create even technologies driven by AI or other kind of soft technologies to make it easier for those people, particularly our scientists in the conglomerate, to better use knowledge graph in a way that is easily accessible for them.
Gotcha. Thank you so much for that, Carlos. And in the panel discussion, really interested in your extended time in Africa, and I believe you spent 13 years in Kenya. So you're literally on the ground and working on these projects, and really understand how to deploy technologies for development in developing countries. So thank you so much for that. Our next panelist is our good friend Damien Dooley. Damien is an ontologist, our ontology development lead at the Center for Infectious Diseases and One Health. It's a 20-member group of bioinformatics and ontology researchers at the Faculty of Health Sciences at the Simon Fraser University, also in Vancouver, British Columbia. His ontology work began in 2013 to support rapid enteric pathogen whole genome sequencing and analysis. And Damien led the creation of food ontology that Aaron highlighted earlier. Damien, I know you're not feeling too well today, but thank you so much for sticking with it. And over to you for your 2-minute intervention.
Hey, thanks, John, and thanks Aaron and Ashley and Carlos. You've all touched on the interoperability issue, and that is sort of the challenge with this vision of a global knowledge graph. It's easy for a company to imagine putting together their own knowledge graph to snatch various bits of information that's important to their own operations. But what I'm really focused on is trying to find a lingua franca of data science, an Esperanto, that allows us to go from one ontology or ontology community to another, and use their vocabulary to provide the names of the nodes and the relationships within these knowledge graphs. But to do that, you have to kind of hit semantic rock bottom. You have to look at a knowledge graph and realize, or have it done in a way that the relationships that exist in it aren't actually hiding a lot of semantic information. So, for example, that one plowing or growing of a food on a farm, that relationship is actually a process with inputs and outputs and sub-processes. So I'm just throwing it out there that if we really want to attain this notion of interoperability, we have to take a look at our own work and see how semantically granular it is. Have we hit rock bottom with our modeling? Now, we don't always want to do that. That would take forever. And academics are working on that. And as Ashley mentioned, the biomedical realm is probably getting closer to that because they started this work earlier. But anyway, just so process modeling, take whatever you've got and try to view it from a process modeling perspective.
Wonderful. Thank you so much, Damien, for that. I often suggest that Damien is one of those people who knows where the dead bodies are buried in the global world of complexity around ontologies. So great resource for us also at McGill, and we love working with Damien. So our next speaker is Dr. Fidel Ndiame. He's a Senegalese national and keen to match economic opportunities available to smallholder farmers with agricultural investment programs that have impact. Throughout his career, Dr. Ndiame worked with global development institutions, researchers, SMEs, and farmers to increase smallholder incomes and livelihoods, involving providing demand-driven income-enhancing services for members, including access to inputs, services, and markets. And of course, he has his PhD from the #1 agricultural university in the world in Wageningen. And up to recently, Fidel was also the president of AGRA. Fidel, over to you for your 2-minute intervention.
Thank you, John. Thank you. Great to be here. But let me just for the record, I was deputy president of AGRA. I don't want to be in trouble with my friend, the current president.
Sorry,
but it's great to be here. But I think my contribution at this stage, firstly, thank you, Aaron and colleagues, for an amazing presentation. And I have to admit, I'm one of the newcomers. I mean, basically, consider that I'm taking a layman perspective on what you're talking about. But looking at it from the point of view of that, for my entire career, I dealt with issue of supporting transformation, people-driven transformation, change in agriculture. My starting career was being a farming system researcher. So when Aaron said that things are connected, it related very well to me. And I think I want to make my comment around 4 points. Firstly, things are connected. And Aaron said very, very well that lack of connection sucks. Now, I want to say that in the real life, things are disconnected. In fact, action is fragmented. And bringing it back into the area of development, to speak, or intervention, I think the reality is that you have a fragmented landscape. Firstly, because of the diversity of the players and the fact that they have completely differential objective and goal, and they're trying to pursue individual goals. And I think what we have learned recently through the COVID crisis and through the food system thinking is you need to find this connection, this reconnection. And I think this is so that we start optimizing on higher level goal than just focusing on a single element. So that's my first point, But connectedness is not just a matter of data, it's also a matter of meaning. People have agency. And I think without getting into the technicalities, I think you have ecosystem that will build around common objectives. And I think beyond the data, it will be important to speak to what are the processes that bring different agencies to agree on a vision of success, on specific role and responsibility, on an accountability system that to drive common action. And to be very concrete, I mean, we know that Africa and most of the countries will not meet any of the SDGs, the Sustainable Development Goals. And part of the problem is we have been pursuing them in a very disconnected way, trying to produce food in isolation to nutrition issue or to environmental sustainability. So I think now what we are learning together with the silver lining of COVID is you actually need to work in a way that brings those together. And again, connectedness that Aaron was speaking to, which means we need to, concretely speaking, to think of policy, institutional, and technical innovation. Now, and the last point of my comment from a layman who's not a data, I'm impressed. I actually looked at the video of the second panelist, which I found very fascinating. Is one comment Aaron made is how do you convert data into useful information? Ultimately, we need to be able to empower each agent through the diversity of position, geographic location, to make sense of the data in order to inform their own decision. So, and this is why I'm interested in this whole food conversion innovation issue, where data and data infrastructure is part of supporting an ecosystem of action of people who are trying to solve a common objective. So this is my initial point. You reference my work to AGRA. I'm pleased to say that AGRA is the go-to African organization that is really trying to help find specific answer to global challenges, recognizing that we are dealing with a vast continent, a significant amount of diversity in a context where you don't have a blueprint. Therefore, there is no alternative to building capabilities for the different level to build their own knowledge graph and be able to operationalize it in a way that is consistent with their objectives. So let me stop it there just to say that I've learned a lot in this session, and I think I can contribute more later, referencing it to real life action agenda on the continent in order to solve issue of food security, nutrition security, employment, and environmental sustainability.
Yeah, fantastic, Fidel, and thank you so much for that. You really hit on what we're trying to achieve with these webinars, and that's the convergent innovation, and that's pulling all of these parts together. So our final panelist is Marie-Angelique Laporte. She's an associate scientist at the Alliance for Biodiversity International and CIAT. She's got a PhD in ecology from the University of Montpellier. Her doctoral research focused on the definition of data standards towards the integration of functional plant trait data and the context of biodiversity studies. In her current role, Marie-Angelique works on the implementation and curation of semantic standards, such as ontologies and metadata, that are used to deal with the inherent difficulty to share and integrate information in agriculture. Marie-Angelique, over to you for your 2-minute intervention.
Yeah, thank you, John, and thank you, Aaron, for the clear introduction and overview on knowledge graphs. I think, one of the big challenge in these agricultural communities is like Fadel said, that research and data is operating in different domains, and often like the connection is not easy to make. And even if everybody is trying to build their own standard, everybody speaking their own language, and that's very hard to come to a middle ground where everybody can communicate easily. And when it comes to knowledge graph, there's also an additional difficulty, I think, is because you cannot build knowledge graph alone. You need expert domain, you need IT people, you need also a bunch of different skill sets to build something that can be useful and robust to derive like information and knowledge. So I think that's really challenging. So one challenge is that we face at CGIAR was really that, how we can all talk the same domain. And something that I really appreciated and I think was a really good approach was having this sort of community of practice where people can come together with their own skill set and share with a larger community and exchange on experiences and knowledge that they are. And I think we had one at that was part of this big data platform of CGIAR on ontologies, and it was really a good place where people started to say, oh, there's so many different standards. I would like to build a knowledge graph. I would like to describe better my data, but I don't know where to start. So having this community trying to just having a conversation starting, I think was really a good start. So yeah, so many challenges. So I'm ready to discuss that more later also.
Wonderful. Thank you so much, Marie-Angelique, for your intervention. And we're delighted to have you and your expertise on the panel today. So we're a couple of minutes behind schedule, but I do want to ask Aaron to come back. And maybe, Aaron, you will get another 5-minute slot later if you want to comment for maybe 2 minutes on what you just heard from the panelists.
Thanks, John, and thank you, everyone, for your kind comments, both the panelists that have just spoken and those in the chat. I'm really glad that the main themes I was trying to highlight seem to have resonated with people, that of interoperability and connectedness, and leveraging these technologies, to your broader point, John, to the purpose of your series, that you can think about ways that this sort of approach can actually solve real-world data problems, and it's not by any means an academic or fanciful pursuit. These really do have real-world impacts, and I hope too, one of the things that, and limited time, but there are no shortage now of knowledge graphs that you can point to that do have those impacts and that are growing and that are used in all sorts of enterprises. So I hope that on one hand that both inspires those working in diverse areas to pursue them, and as well that they serve as both an inspiration and source of knowledge for those that might want to pursue these sort of solutions.
Wonderful. Thank you for that, Aaron. Now, for those of you who weren't here at the start, we will rest Aaron for the next 43 minutes. And I'd like to invite my co-chair, Anna Fensel, and all of the panelists to open up their cameras. And I'll pass now over to Anna. I may jump in at some point with some questions. But I'll rely on my guest co-chair, Anna, to lead the conversation for the next 45 minutes. As I mentioned earlier, we reserved the last 15 minutes of the session for 1 minute closing comments from each of the panelists, 5 minutes closing comments from Aaron, and then for the last 5 minutes, I will share closing comments with my co-chair, Anna. So Anna, over to you.
Yeah, so I think the procedure is that, well, we will go through some questions and there will be discussion, and the panelists who feel most, or everybody should answer the same question or not necessarily.
Yes, I think we need to, go deeper into each of the questions that you may have. The panelists may even have questions for each other. I think one thing that's very important that Aaron mentioned, I think Marie-Angelique mentioned as well, is the multidisciplinary need to get all the disciplines together. I often say we need all of the ologists around the table. So it's good to have people from different backgrounds and different functions on this. So over to you, Anna. And if I doubt you're going to run out of questions, but if you do, okay, over to you.
Perfect. Well, first question. Well, of course, very nice to meet you all. And I have also seen that, some of you at least worked with different backgrounds and also with knowledge graphs in different areas, not only agri-food. What do you think is the key difference or key specifics of using agri-food, using knowledge graphs in agri-food, and which kind of solutions we should be looking first in this area?
I mean, if I can start. Yeah, I think in the agri-food domain, one challenge, again, it's like the data are not maybe ready, or I don't know, or I think there's data all over the place. I mean, there's data produced by researchers, by agencies, by so many different types of organization. Private companies are also, private sector is a big producer of data in that domain. But yeah, having this global view of the domain and having the data to feed part of the big graph, I mean, is still hard to get. I mean, that's my feeling. I mean, from the CGAR, people are still working in Excel file. They are still, so then the gap to go and to jump to knowledge graph is quite big. So I think we need to find also solution, acknowledge that and find solution to try to reduce that gap.
Well, just to continue on with that, my biggest piece of advice for anybody trying to get into knowledge graph is start with a very small, very specific use case that's going to give you the most benefit. And that's actually the beauty of knowledge graph, is it's so flexible that you can start with a use case and then just continue to add use cases as you get more familiar with what data do you actually need? Where are you finding those benefits from this kind of data? So that would be my biggest piece of advice.
Yeah, I think as in terms of agri-food systems and the context of CGR, knowledge graphs can help us, for example, understand dynamics that we had never thought before. For example, a question that sometimes we could ask is like how the production of particular food can exacerbate, conflict due to climate change in the south. Because most of the raw materials come from the south. You blend it into food, and then food that is sold, for example, in the United States. So how the production of food can exacerbate those conflicts in the south, and that is something that if a knowledge graph can actually maybe point us out to some direction. But as Marie-Angelique Laporte said, like, how we can start moving from data into knowledge, from data into fact, into interconnected facts into knowledge. That is something that starting small, definitely is the way forward, because otherwise, it's a humongous undertaking. But even that, I think it's for CGR, what we need to do is start categorizing our data connected with ontologies, making it like interoperable, and that is something that we're doing right now. We're getting better in that, but it's something that a process that maybe I've been with CGR, I don't know, close to 20 years now, and it's a process that maybe has started maybe 10 years, and that is going on and on and on and on. Not easy, but it's something that we need to, all the discipline has to work together in order to achieve it.
Maybe I can come in here just to build on Carlos. I think from a practical food system transformation agenda, I think you are dealing with the challenges of really bringing together a set of actors that need to cooperate for a certain goal. I think Aaron referred earlier to a supply chain. It could be a value chain, but more recently, you have a number of initiatives that really bring together the whole sector in order to improve, to deal with issue of food safety, for instance. I think we have a concrete example in Nigeria, for instance, where the whole sector is dealing with the issue of aflasafe and aflatoxin, which is really causing not only a health issue, economic, but also creating significant environmental challenges. Now, to solve a problem like that, you can't do it in isolation. You need to bring on board from the consumers to the producer, the policymakers, the logistic people, etc. Now, this is where the mapping, the graph or whatever you call it, is you need a mental mapping, an alignment of the mental map. Basically, what is the task at hand here is to have a shared understanding of what the opportunities and the challenges are, to articulate a vision of how they are going to win together, to have an action plan that is understood, to be able to act, and also to have a mean to assess it. I call it the 5A. You analyze, you articulate, you build an alliance, you act, and you assess. This is a concrete life. Most of the issues we are dealing in the real life require cooperation. And this is why we need to go beyond the data into the information and go back to the idea that knowledge is actually an emerging property of the social engagement. I think I'm very impressed with the technology and the complexities, but going back to the basic is what do we need it for, who needs to use it, and what purpose, I think set us in the right direction. Thank you.
I can add.
Yeah, please.
Okay. Then that touches on a number of things. So of course we're involved in our CIDGO Center in foodborne infectious disease, and that's one of the discriminating things about this whole sector, that you're dealing with perishable goods and they can carry disease, and so there's really high motivations to do traceability. So that's the motivator, the problem to solve. The one issue is that well, let me just say, I've seen the evolution. Government agencies have been a bit more friendly to explore this notion of an open source public ontology to provide the vocabulary for describing the biosamples, for example, foodborne pathogen biosamples. So they're like the second. Academia was the first wave to get into ontology deep. Government agencies seem to be the second wave. The barrier on the commercial side is this competitiveness, this intellectual property layer that makes them want to own their information. And at the moment, I think they can't distinguish between the language the information is coded in and the information itself. So what we have to do in the open source vocabulary, data Esperanto world is convince them that they can at least provide views of their information in an open source language, without compromising their intellectual property and whatever secrets they keep on the stack the rest of the way up. And so I think the government agency is not such a barrier to them, but the companies are the last to get into this. Not that standards haven't been around in ISO and other kinds of standards for collecting data. GS1 is actually industry driven, so, but this conversion to the open source language of ontology in general.
Mm-hmm. Nice. Yeah, well, we discussed that of course, it's required basically, well, collaboration, and that people should, well, try to solve their small cases, and we hope that it aligns in some big case, and we solve also problems which are important for us all, like sustainability goals, meeting of them. But do you think it will be, or how can we ensure that we have maybe such methods or tools or practices that people also, well, use knowledge graphs and make their data available and share the data? Because this is, of course, well, as long as it goes beyond solving their small use case, probably nobody would be interested. So how do you view this? And especially, well, in agri-food sectors, it was also mentioned it's a very conservative sector, so it's we observe that there is data is not represented in well-structured format, that there is also lack of people who can, well, put it in a knowledge graph format, so they really face complexities on many sides to deliver this data, to have such data ecosystems. So how do you view this?
So I can actually speak from a real world example. So I was involved in the electronic space, like IEEE, when IoT, the Internet of Things, became very, very big. And all of the big players had to get together to figure out what data sets they could actually share, because they had all of this proprietary information that they couldn't share. But they also realized to make IoT work correctly for their industry, they had to come together and agree what kind of information they could actually share. It was a big meeting, and there was a lot of heated words, but at the end of the day, we came out with an agreement, a standard that was going to be worked on what information could be shared from, Garmin, from Cisco, from like all of the different systems that were to be involved. I feel like something like that would be helpful here. The other thing I wanted to address from your question is, and it actually really resonates with a lot of what Fidel was talking about, is you can't miss the human component. A lot of us get so excited about the data, sharing of the data, but most of us are data people. People that are not data people, they miss out. And I am a huge advocate of citizen science, making sure that the intelligence of every human being can be captured in a way that even my grandma can do. That's my status. If my grandma can enter this information, we have succeeded. And that's where, Aaron did allude to it a little bit, which is more personal knowledge graphs, which is, there's a lot of definitions for it. My definition of this is, I, as an individual, not a data person, can still input my information and understand, where did I buy my lettuce? When I see a recall for that, where does that affect me? Having ownership of my data is a very big part of this, and being able to enter that as a lay person is incredibly important. And we're just not there yet. But I think that those two applications are the critical path for this to work.
Maybe if I can just build on that, Faith. There is a case in Kenya. Carlos, you're sitting there. During the COVID crisis, something fantastic happened, and in the form of what they call war room. But what it meant is the situation was so tough that people came together, government, private sector, farmers, everybody came together just to share information on what is needed, where, by when, and who has that information. It translated into a war room, which enabled to avoid a major crisis. I know the whole issue of proprietary data, etc. So under certain everybody realized that we actually can survive together or we will perish together. Now, you don't want to have those extreme cases. This is why I was referring to what are the policy innovation that enable us to take on several higher level goals, that will compel us to cooperate around data, knowledge, and action. Because ultimately for me, data is just a reflection of social processes that are being captured. You have what? So how do you bring it back to re-socialize it so that it feeds our information? Now, I'm not naive to know that you have a lot of commercial interests, as one of the panelists was referring, I think it was Damien. But where is the limit? I mean, there's a sweet spot where cooperation will not kill competition, but we need to cooperate in order for a greater advancement. And I think this is why we need to bring the human agency. Ultimately, and this is why I think the current conversation around the food system is really to tackle simultaneously prosperity, people, and planet. I think that framework will enable us to consider all of these issues, but in a real world situation. That's my input on this very important topic.
Yeah, I think it's coming on the issue of the private sector and the reluctance to provide information on the. It is also, for example, even at one of the issues that we have on the public domain, for example, CGR, is the issue of more or less like the reluctance of scientists, for example, of making available data, because of there is that feeling of somebody is going to look at it with a closer eye, or they're going to come to different conclusions than the ones that I came, in my publication. So it is that feeling of misuse of the data, when it's in the public domain. But it's come from the fact from the scientists of being scientists. Sometimes if you, for example, if you ask a scientist to write a scientific paper, he will maybe write it, no problem. But it's going to ask him to write a blog, summarize that paper in maybe 3 phrases or 3 paragraphs. He can't, because he wants to be so complete and so specific that it's impossible for him. The same, but like when he's going to create, for example, even facts from his own data, facts that then can be connected into other pieces of data. That is very complicated. But I agree with Fadel, is like, we need to create policies, appropriate policies for bridging that private and public sector, to create frameworks for public and private sector engagement that you will not require, a situation of war, like or panic, rather than an appropriate action before that happens, but we need to start looking into that.
I can add that wouldn't it be so great if actually all the ontologies were already finished and we had all the vocabulary at our footsteps, at our fingertips? It turns out these ontologies a lot of them are jello. In fact, they need to be curated. We have to be inventing, especially in the sciences, left and right, and in industry, the terms that are the semantic foundation upon which these knowledge graphs are composed. So I would say that where it changes from being a war room into a bit more of a library grotto is that to really have an ontology with legs is to have a curation team behind it that's multi-agency. You're bringing together people from different agencies, all with a vested interest in the same language. That slows things down. Within an hour, you're lucky to curate 5 terms to get through 5 new terms, and especially holding to with all of the axioms. And I can say this because I'm a curator on the ontology for biomedical investigations, as well as Foodon. We deal with this all the time. So Foodon has, for example, 300 food processing terms, but we can easily imagine that the terms involved in laboratory protocol are equally applicable. You're cooking up something in a beaker, you're cooking something in a pot. It's the same thing. So there's this whole need to transition specific vocabulary to general vocabulary, both relationships and entities. And all of this requires a joint curation process and the training for the platform to enable all of those URIs to be patterned in the same way and using the same relationships. So it's formidable. I'll just say we have a monthly call, interagency call about food ontology. So people may be interested in that, attending that. If so, let me know. And otherwise, I would advise anybody really wanting to participate, get involved in, say, the Industrial Ontology Foundry or the OBO Foundry community. Pick an ontology area that you're interested in and see if you can find a curation team. That will really get you into the semantic level. To be able to create these graphs that you can just throw together rather than doing this one-to-one mapping, which most people have to do right now. Last little thing, so schema.org, you know, the point was made, well, what about recipe cuisine and recipe ingredient? Well, those are free text fields. That's the problem. That's why schema.org only goes a certain way. We actually have to make sure that each of those references is an ontology entity. So there's so much work to be done in that way.
Yeah, and I agree. I mean, as a curator of ontologies as well, that's really a challenge, like to be able to translate a shared understanding of something into the semantic standards is quite challenging and end up being long discussion and exchange. And that's also what's really great in that domain and what I like, and really in the domain of building ontologies or building standards, is that you have to really discuss and exchange with different types of people from different backgrounds on different topics, and that's really that's cool. I mean, to not live in isolation, but really being open to the different views of people on different things. And that's particularly true in this agricultural domain, where we go from the farmer to, you know, the processors, and then, you know, to the supermarket at the end, or even like you said, like the health domain and all of that. So that's really great. Also, that's a chance, I think, to be able to work on these standards. But yeah, having a community that is strong enough and that really wants to share a standard it will be key, I think, in the success of having this technology implemented. And that's the case at the policy level. Like, you know, you can recommend that now we should be using data standards or ontologies, but which one? How can we come together and build something that is going to be huge? But at the same time, I mean, can we really not do that? I mean, I don't think so. I think we all need to come together and work on that and tackle that issue.
Maybe next kind of a logical question from here. With the project, as we talk about ontology development, and that we still don't have enough of them for many areas, and for which ones we have, they go very slow. How do you perceive, maybe who of you are involved in this kind of efforts? Do you think, well, you get enough resources in terms of money and people to drive it as you like it to have? And also, do you think is also maybe also in agriculture we will have the same type of developments as in some other areas where, for example, Google comes and says, okay, this is schema.org and this is knowledge graph and we have done it and take it or leave it? So are we running in the maybe same risk or same scenario in agriculture area, or it's still way too diverse for this, that somebody comes and takes it? Elon Musk buys some company and says, I'll do this.
Anna, let me start and being also very concrete. I think the challenge with agriculture is you really need to manage diversity. Because if you think about it, I mean, I think Aaron made reference to the supply chain. which basically is a way of thinking from the input to the consumer, from the farm to the fork. But you also need to consider geographic layers from the local, national, regional. So any collective action that requires building a language, finding a standard, agreeing on standard operating procedures has to be interactional. You basically need to have a process of engaging people to pick up their view. And I think the worry I have, just to take the example of Google, I don't even know what they do. If you have a central team that is able to map out everything and then pass it on, we have failed. The challenge is, can we find a language that speaks to everybody so that they have a pathway to solving a common problem? In the case of the AFLA-SAFE I'm talking about, everybody where they are sitting have an incentive of doing it because the producer will not sell if he doesn't meet the standard. The processor will not sell if he doesn't meet the standard. The policymakers will suffer if the country's products are rejected. So you have a case for cooperation, but the methodology of doing it requires what Marie-Angelique was talking about, specific engagement with these different. And the way I can visualize it is each college have to have their own conversation and understanding of the problem, the solution, and have it connect to the bigger scheme. It requires orchestration. That facilitation, it has to be built on trust. And Carlos, I'm sorry to say, I've been a researcher myself. Unfortunately, the competent expert technicians are the least equipped to facilitate those conversations, because as to the point Carlos was making, they're specialized, they have their own incentives. So there is no incentive to really create this ecosystem that has to be shared and work for everybody. From where I'm sitting, this is where I see how it's a real life challenge of how do you manage diversity to come up to something that serves everybody. And this is where technology should help. It should not be the other way around. We shouldn't be fighting to match the technology. It should be the technology helping us solve the real life situation that will enable us to do people, prosperity, and planet. Over.
Yeah, I agree. They have different, scientists and technical people have a different kind of, perspective of even where they reach. For example, even sometimes even scientists says, in this silly way, they said some of them said, I reach onto the level of paper. Whatever happens afterwards, is not my issue. But it comes to the fact that then it's like the amount, as Anna said, what is the amount of the resources that we have. If we talk about that inside CGR, which is our big conglomerate of centers, the resources for example, even for working on ontologies, for creating knowledge graphs, so bringing up these technologies are very little, comparing to the resources that maybe other organizations have, like Google and so on. And I see, for example, groups that are here together today. It's like Center for Ontological Research, group of ontological this university. If you look at us, like we don't have inside CGR our own group of ontological research. We are like a Marie-Angelique, me, and for example, Elizabeth Arnold, who was, I think she's here, or maybe she departed. We are scattered in different places in the world and trying to make, the best with our efforts to drive the process inside our conglomerate. But it is difficult. Bit by bit we go. But we different need resources and also expertise from other centers.
One thing I want to comment on that. Oh, sorry.
Yeah, just to add on Carlos, just to explain, the way we are funded for the ontologies or semantic standard work is really by project. And so the project usually are maybe 3 years long. So, at the end of the project, there's still a risk that the standard that you put so much effort in building and people starting using, and, then there's the risk that it stops. So that's really a challenge also, like how can we have a community engagement for these standards so the long-term the long-term sustainability of the standard can be guaranteed. So I think that's a challenge. So yeah, please, over to you, Ashley.
I was just going to mention, there's a lot of talk about lingua franca making one vocabulary, one thing to rule them all. That will never work. But here's the thing. Knowledge graph actually is one of this is why I got into knowledge graph, is it allows everyone else to contribute the words they use. I call this their natural language, not natural language processing. That's different. The natural language that you and I talk to each other, that's discourse analysis. Go look up Hobbes' discourse analysis. This is what normal human beings use. And it goes down to not just your geographic region, but who are your neighbors? Who are the people that facilitated your homework or meal making when you were a child? That's the language all of us have in our brains that is our mental model on how we connect things together. What a knowledge graph allows you to do, and I do this in my day job, I have videos on my channel all about this, and I teach it for free because it is so incredibly important, is you don't have to all agree on the same word. You use the word that you are the most comfortable with, and then the knowledge graph folks can find out, oh, all of these different words and all of these different languages and dialects actually mean the same thing. That maps up to a class in a knowledge graph. So the knowledge graph isn't telling you, dictating who is correct. It's saying you're all correct. And when you do a search on my knowledge graph, you can use whatever language you are the most comfortable with. And no other technology that I have found allows you to do that. And that is one of the strongest pieces to going into knowledge graph for what we're talking about here.
I would say synonymy and linguistic use in different regions and mapping over to some deeper semantic level. It's that deeper semantic level that I'm talking about in terms of lingua franca, not the spoken language. So we run into that a lot with food on too. Whether Elon Musk or some other monopoly will be able to take over this language and offer it as a corporate standard, and we have to buy into their systems. Well, is happening in agriculture with companies trying to own the information coming from farmers on the field and not even letting farmers even see it. So there's this big move to democratize agriculture, and we do see that open source vocabularies are one way to do it, and to try to break this siloed information collection. But that is a bit more of a political battle than a technological one.
I've noticed too, a lot of companies, I deal with a lot of the agro companies in my day job. And what I'm trying to, and it's information literacy. People don't own words. They don't own words. They own the composition. They own how you define that word. They may even own the ID that they assign to it, but they don't own the actual word. Some cases people copyright words. That's a different story, but that's very, very rare. I've done in-depth analyses across different vocabularies that are open and some that are not open. And all of them that say they're so proprietary, only about 10% of their terms are actually unique because it's language, we don't own it. And just getting them to understand that on the corporate side is an information literacy task, to make sure that they understand, yes, it's your IP, but it's the composition, it's how you define it, not the word itself. And so maybe that would help us open up some more of those doors.
I think I'm probably getting into an area that is not mine, but language is the channel for meaning and culture. And I think this is why it's so important. It's like food. I mean, we all talk about healthy food. What does it mean? From Senegalese like me, from the Casamance, it has to have kucha. You don't even know what kucha means in your own. So it's so important. And this is why I'm agreeing with you, Faith, that this capacity building, this making sure that people can own the methodology and speak the norm, speak the standard, and socialize, exchange, because it's not static actually. It's something that is quite dynamic, and we see it happening. For me, ultimately what matters is how does it inform meaning and action, because all of these are linked. And this is why you start having, a differentiation based on, certain standard, etc., that have significant implications. So I think what you're talking about is so important that I like Damian's point around democratizing access to data, but more importantly to information. There is a whole translation piece, that is so important. People are completely left out because they are not part of that whole process. And one of the agenda we're following is inclusive transformation. I mean, if you don't take it in, you have an exclusive. I mean, and I think this is Professor Loret is trying to educate us on the difference between economic convergence and convergent economy. The convergent economy is happening through the big guy forcing onto us what we need to do. Economic convergence means we all find pathways that converge towards something that is important to follow us. And I think this language graph and all of that can contribute to that broader vision of having a plural and more sustainable food system, at least from where I'm sitting.
Yeah, so it looks like among the panelists, there is a kind of vision that it's working towards a kind of Wikipedia for agriculture, where everybody shares their culture in terms and somehow it works together, hopefully. But Wikipedia, of course, is a very good example for things which is decentralized and not run by Google, run really by people. But of course, agriculture is a little, somewhat different because we also have a lot of data which is very sensitive, as is known, and cannot be shared. And also, people would share it, but on the certain conditions. For example, farmers also will not be. I mean, it's not putting your advertisement on a web page to be more visible in schema.org to be more visible by Google. It's some other scenario which would need to motivate people, but also we would need to control somehow transparency and trust in the system, maybe also manage consent, which is already we do in many systems, that people consent to do data on certain conditions, and there are contracts on how data can be used. So it's really something becomes very tangible. So do you see it also here, and do you think it's more or less would be working like in other areas, like it starts to work in other areas now? Or is there some differences? And which tools maybe we need as well, or solutions to access this closed, data which are having access management for the data, but also having findability for this data. So it becomes quite a complex system.
Right. I guess I can chip in. I've learned through John Keogh and some of the blockchain stuff that the transition is happening here between thinking of information that flows along traceability line and thinking of it as one partner handing off a package of information to the next in a telephone kind of game where stuff is lost along the way and only what they have to hand to the next person is carried on. So the paradigm is changing. Now there's a central vault. The information identifiers tracking along with the information allow anybody anywhere along the line to add information into the vault. Now, the thing about blockchain is it only allows some people to contribute. And so it's an interesting idea that maybe all of the folks who want a bit more of a social democratization about where that palm oil came from, whether it's ecologically healthy or sustainable or not, does that information get onto the blockchain if only corporate players are contributing? Maybe we need a second public blockchain that comments on the private one and provides all that extra information in the open space about that, for example.
Yeah, I love that. And another approach that I've used, while definitely not as scalable as probably what Damien is discussing, is getting the subject matter experts and their natural language and their cultural piece to how they define something. AWS has a tool that allows you to select certain SMEs. So you're not just giving it to everybody. You are making sure there is some kind of credentialing to make sure that, somebody actually, especially with the sensitive information, that somebody has some authority over discussing this. And it's actually a tool used for creating machine learning training sets. And basically what it is instead of sending SMEs a training set for machine learning, you're actually sending them a data set very similar to what you would see here with either terminologies or what looks like a triple, right? Like seeing how one thing is related to another thing. And the SMEs can curate that. And it's an automated process. You can even pay your SMEs through that, I think using the updated mechanics of Mechanical Turk. I've used this in my past to a very high success. So that's another avenue that you might want to think about.
So we have about 2 minutes before we go into the individual closing session. So if anyone has a follow-up thought for this for the next 2 minutes, for that question. If not, let me ask a quick question. Capacity building. I know that Ashley is doing a lot of capacity building with her education programs. What else needs to get done on capacity building to educate the different communities on what's possible? Fidel, I think you may have some thoughts on that. You're on mute. Yeah.
Mute. Yes. Yeah, I think there are some fascinating peer reviewing mechanisms because as Ashley was talking about, I think what you need is almost like a process by which people who share a concern, a geography, a group, can start talking among themselves about what is important and documenting their own practice. It will get to a point where, as a collective, they have a language. So this is the social. This is an outcome of social. Now, if you do that across geographies, it actually provides you a kind of a benchmarking process. I'm sure you know, from tacit to explicit, 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 tacit, tacit to explicit. It's like the Nonaka cycle. In practice, what it means is you involve people who share an area or a domain. They have a language about that domain. All taxi drivers across the world share certain things about the way they drive, etc. Having a process that can be along the line that faith can be made in a very systematic way. Another example is what the African Union is doing around the peer review mechanism. Around the Malabo Declaration, there are some specific goal and target that are set. Every 2 years, you have a biannual review where the data is shared, they do some result and reporting, and it is discussed at the highest level, and you have a way of knowing in a common area who had made the most progress. And that trigger cross-learning that happened because people can see that they share similar experiences.
Wonderful.
So I think this is something concrete that we can absolutely pursue.
Wonderful. Thank you for that. So now I'll take over from Anna again and just go through each of the panelists for a 1 minute closing. We do have to keep it to 1 minute closing. I'm going to start with Marie-Angelique. Your 1 minute closing comments.
Yeah, so thank you. So yeah, so it was a great conversation. The different perspective of people, what they bring to the discussion is very interesting to me. And so I think I want to come back to your capacity building. And I think that's really a need in this agricultural domain, where really if we want knowledge graphs to succeed, and having ontologies and better data and then derived information and knowledge, I think we need to start learning from each other and engage in these big communities, maybe through community of practice or through different means. But I think that's really important to find a way to learn together, because that's all new.
Wonderful. Thank you so much for that, Marie-Angelique. And our next is Fidel. Your 1 minute closing comments.
Yeah, not really to appreciate being part of this discussion, which I hope is just the start of a new conversation. And I think I really want to go back to what Aaron said earlier around connectedness is the solution. But I just want to pursue that actually knowledge by definition is one of those commodity that doesn't decrease when you share it. So, and I think that this should be the incentive when you talk about not data, but knowledge, of promoting the social engagement that enable people to co-create meaning, that then enable us to have a body of knowledge that can be shared and that can be actionable, that are relevant contextually, but also speak to a global challenge.
Fantastic. Thank you so much, Fidel, for that. Damien, your 1 minute closing comments.
Okay. Yeah, all of this is so good. Just evolutionarily, it's exciting to be at this point in the development of it all. It's exciting to watch government agency staff getting educated. And I would say, yeah, it's just a complex spot we're in between training and harmonization. So I think as much emphasis can be put on the harmonization side of things as a priority in training, because if we just do knowledge graphs that are not interoperable, are one-to-one conversions, then we're left in this insurmountable space of having to translate every graph as we come to it. That's no fun at all.
Thank you, Damien, for that. Carlos, over to you for your 1 minute closing comments.
Yeah, I think it's, we don't understand the potential. We have seen the potential on knowledge graph to change the life of, for example, our beneficiaries, people, but what we need to look at it, and is a combined effort in order to bring this technology to properly apply it in a meaningful way to realize that impact. And something that we have to do ourselves is because more interconnected, because it will depend on like in a group of like this one today, and how we can collaborate together, that we can actually make it that realize an impact from knowledge graphs on the ground.
Wonderful, thank you, Carlos. Ashley, over to you for your 1 minute closing comments.
I couldn't agree with everyone here more. Damien, a lot of what you just said is very, very relevant. I think that, while knowledge graph is incredibly important and makes a lot of this possible, don't worry so much about that. More like what data do we have now? And there's a lot of taxonomists out there. There's a lot of information professionals out there that they know data and they can help start to put these mappings together without knowing a darn thing about knowledge graph. So that's my parting words is let's try to upskill the people that we have in our networks. There's a lot of great, Discords, meaning the service that you go and talk to other people, as well as Slack channels for these communities of practice that already exist. If anyone's interested, let me know. I can share those with you. Just start to think about it from the interoperable mapping perspective first, and then knowledge graph eventually comes along for the ride. So that's my parting words.
Wonderful. Thank you so much for that. I'd like to invite Aaron back for his 5 minute closing comments.
Thanks very much, John. Everyone. In terms of, I was thinking about how I could close, and Ashley kind of stole my thunder, because when I was thinking of what words of wisdom I could impart is when working on a knowledge graph initiative, start small. Having said that, I think I can maybe extend the thought, and based on my many failed efforts, provide some practical advice for those wanting to get into the knowledge graph construction game. First, anchor your efforts on a concrete, obviously helpful, achievable use case. This will both maximize your chances of success and build the foundation of future work by having something that worked and is useful and that you can point to. To state the first point yet again, don't boil the ocean. For smaller projects, there's less risk of disaster if you fail, and less technical debt to remediate if you need to modify your approach. Do not rely on the tools to do the heavy lifting for you. Knowledge engineering is hard, at least it is for me, and even now the quality of of tools available in this area ranges from fair to bad. There's still a long way to go, and tools are not going to solve your problem. To rehash a quote from James Hendler, you've almost certainly heard before, little semantics goes a long way. Damien, your point about the string attributes that should be relationships in schema.org is well taken, as is the off-cited lack of identifiers for the vocabulary. But baby steps predicated in some sort of standard still get your skin in the semantic game. And this is especially true, I think, of taxonomic development, where they may not be OWL ontologies, but SCOS taxonomies can be incredibly powerful. Engage with, and I see Ashley was doing some typing on this, engage with others in the linked data community, especially those outside of your own domain. I would say that too, you know, I'm doing this for a while. I've worked in, you know, video gaming and products and all sorts of things. Oddly enough, the very first exposure I had to semantic technologies was a rice ontology, right? So you can get the juices flowing by having those sort of intersections. Go to conferences, both of an academic bent, and I think especially those that are industry facing. I say that especially because enterprise commercial knowledge graphs are by necessity focused on practical applications of the technology. Join the Knowledge Graph Conference Slack. It's free, and I'm just pasting this in the chat. There we go. And this will enable you to connect with all sorts of great people in the field. Follow me on Twitter, which I've also pasted in the link, not because I want or need new followers, but because I am a compulsive sharer of linked data information, as anyone who follows my online can attest. Just 2 more points. In developing vocabulary for taxonomies, and especially ontologies, don't include terms or entities or relationships or attributes speculatively. It is unbelievably easy to add clutter and confusion to your vocabularies. Stick what's required to satisfy your use cases. If you're using the standards and taking an extensible approach, you can always extend your taxonomy or ontology later when you actually need to. And finally, for initiatives of any notable size, make sure you have the right skill sets on your team. Again, some of this is very hard, and you'll be better off if you have people with the right knowledge on board. Or to allude to a point I think you made, Ashley, to at least work on upskilling your existing workforce. Other than that, I'd just like to say thank you to John, to all the panelists, to all the participants that have been part of this presentation and discussion. Thank you.
Wonderful. Thank you so much, Aaron. I'd like to welcome Anna, my guest co-chair for today. And Anna, open up the floor for you for 2 or so minutes to comment, do some closing comments, and also maybe talk about what your goals are within academia at the #1 agricultural university in the world at Wageningen.
Thank you. Yeah, very nice to have been at the event and been able to ask questions also from that what people think of the other parts of the planet. Yes, so I think it would be, well, I think we are in a very responsible position now, all of us, to build a system which bring agriculture forward and also stay to be inclusive and meet overall goals we have on the planet, like sustainable development goals, and food safety also comes very soon in question, and for some regions it's already very hard already now. So this is of course very big challenges. But on the other hand, also I saw that resources in the or development in the domain are scattered. So we have people setting up smaller projects which are eventually growing together, but still there are challenges. For example, capacity building is a challenge, and this is also some of the things I also observe in Wageningen. Well, by background, well, work in semantic technology field for almost 20 years already. And, but at Wageningen, I started a year ago, and I've already seen that, of course, this is all what we discussed now also applicable for the top university of the world in Agri-Food domain. It's also, there is a lot of integrating data industrially, scientifically, putting it together to work on the to reach bigger goals. So this is very important and very challenging. It's also one of the reasons they also hired somebody like me to join and capacity building also. And in this domain, it's also a little bit technologically a bit behind. So there, for example, when I came, it's well, we're building up data science and artificial intelligence because before it was not well, there was some information technology education, but agriculture also becomes very, very digitalized, and it's very, you need advanced already things. And this is, of course, also very important, and there are really, really many challenges to solve, and also to continue that we have the systems working, and with, particularly with this technology, with knowledge graphs, in bringing us together to the good conditions for everybody. So these are my main
So, Anna, as we parachuted you in as the guest co-chair, thank you so much. You did a fantastic job moderating the panel. Ashley, Carlos, Damien, Fidel, Marie, Angelique, thank you all for your contributions. We're not only, doing capacity building for real-world solutions at scale to address societal problems, we're also building networks of a lot of big brains that are on the panel today and on the discussion, and there's more big brains in the audience as well, listening to this excellent conversation, very broad conversation, and we need to bring it to the next level. We need to start implementing rather than continually talking, but because this is a new area, it's fast evolving, we do need to get the word out there as much as possible. I want to thank you all sincerely for, again, taking time out of your busy day to help share your knowledge and wisdom with us. Stay connected, keep connected. Also, you may want to register on the McGill website to get updates of our upcoming webinars. And we would love to see you back again as panelists or keynote speakers and so on. So with that, we finish on time. And thank you all. Have a great rest of the day, afternoon, or evening. And our best regards from McGill. Thank you.
Thank you all. It was great.
Thank you very much.
Thank you.